So out of the box, Angular comes with an NgFor directive, which allows us to iterate over a collection and stamp out an instance of a template for each item in that collection. Now, the default behavior of NgFor is that for every change detection digest triggered in the parent view, it looks at the contents of the collection to see if new items have been added, old items removed, or existing items been moved to a new location within the collection. Now, this is really fast and efficient the way Angular does it, but in cases where we know that the input, the collection itself, is an immutable data structure, we can actually short-circuit some of that change detection processing by only inspecting the users if the reference to the collection changes, or the input binding for the NgFor changes. Now, there's not a setting on NgFor for that, but what we can do is subclass NgFor to create a new directive that slightly changes this change detection behavior. So NgPureFor, pure here meaning that it's going to respond only to changes in the input bindings, is going to subclass NgFor and only inspect the users if the user's collection reference changes. Now, to test this, we have two actions that we can take on the page. We can either swap the collection itself, where you can see we just essentially duplicate by slicing the user's collection, or we can swap the items, in which case we loop over the collection, and then for each collection we change the item reference at the existing array index. So we keep the top level user's collection, but we're changing the contents essentially. And as we change the contents, we're going to increment the ID so that we can see here whether or not this value gets propagated to the view. So let's jump over to the browser and let's refresh, make sure we have the right data. So here I'm just going to start swapping collections, and I'm clicking here, and you can see that we're not seeing any changes in the view because we're not changing that top level user's collection. So the NgFor isn't inspecting the collection to see if new elements have been added. Now if I go to swap the collection, we're going to change the input bindings, which is going to trigger the NgOnChanges of our NgPureFor directive subclass. And here we go. And you can see all of a sudden all these updated, right? So again, if I click on this a bunch of times, we see new changes, but then if I swap the collection reference, boom, you can see all those values just updated. So let's take a quick look at how this works. So what we'll see is that we're creating an NgPureFor directive using the selector NgPureFor instead of NgFor, and of course it's going to use NgPureForOf instead of NgForOf, and it's going to extend the generic NgForOf directive that's being provided by Angular. Now, the way that the NgFor works, again, is that it binds to the ngDoCheck lifecycle method and it inspects the provided collection during every change detection. But we don't want to do that. So what we're going to do is in our subclass, we're going to override that ngDoCheck lifecycle method, and we're going to turn it into a no-op or no operation method, meaning that even though this is going to get invoked on every change detection, it's not going to be doing any work. So it incurs essentially no overhead. Now what we want to do is respond to changes in the inputs and use that to trigger the inspection of the user's collection. And to do that, we're going to create our NgOnChanges, which is going to be invoked when any of our input bindings change. And then when the input bindings change, we're going to go ahead and turn around and call the super doCheck method, right? So that's going to be the NgForOf doCheck method, which, as I said before, is what's actually triggering the inspection of the bound collection. So when the input changes, right, when these input bindings change on the NgPureFor directive, the NgOnChanges lifecycle method of our subclass gets called. The subclass then turns around and calls the superclass, triggering the ngDoCheck method, which turns around and inspects the user's collection. Pretty easy, and there's really almost no logic here. The only logic that we have to really provide is aliasing the properties on the inherited NgForOf, right? We can't override, or let's just say we don't want to override the NgForOf selectors because we don't want to mess with the existing NgForOf usage. Instead, we want to create a new selector so that only our directive, only our subclass directive gets applied to the particular template. Of course, we don't want to have to duplicate all of the logic, So we're actually going to just say that all of these existing inherited properties, NgForOf, NgForTrackBy, NgForTemplate, we're just going to alias those to have this NgPure prefix. So essentially this is just the metadata that Angular uses in order to know how to bind template attributes to these class properties. And then above and beyond that, we don't have to do anything else. The aliasing just sort of does the work for us, and then the inherited properties and behaviors of NG4 fall into place automatically. So there we go. I think this is just kind of a very fun exploration to see of how we can actually extend the built-in behaviors provided by the Angular directives, and with very little work. Now, keep in mind that this does not affect the change detection within the template itself. That's actually controlled by the parent context. This is really only providing a micro optimization on top of the input bindings for the directive, so that we don't incur that overhead, albeit tiny overhead, of having to look at the collection during every single change detection digest. Ultimately, if we really wanted to squeeze the best performance out of this, we would take this and move it into a component that has on-push change detection, and that way not even the template context would be checked unless the inputs to the component or the change detector ref was triggered explicitly. But again, that adds a little bit more complexity. It goes beyond the scope of what we're trying to do here. This is doing nothing but adding that micro optimization on top of the input bindings for the loop directive, in this case the NgPureFor, which is subclassing the native NG4.